from Computer Science Engineering Department. So today I'm going to discuss about the topic analog and digital signals. Okay, it is one of the useful topics in data communication. So as you all know that data is nothing but the processed information, okay, that we consider. And what do you mean by the signal? It is some kind of information that is carried through some transmission medium that is known as the signal. So if we talk about the signals, there are two types of signals. One is the analog signal, another is the digital signals. Okay, so let's come and let's compare between analog and digital signals. So as you can see, analog signals are in the continuous waveforms. They are continuous in nature, whereas the digital signals are in the form of discrete values, right? So analog signals have got infinite range of values. Okay, it can be from zeros to -1 to some infinity, right? Whereas digital signals, they are having some finite range of values. Okay, like suppose 0 to 5 or 5 to 10, some kind of limits are there. Then analog signals, it provides more exact values but more difficult to deal with, right? On the other hand, if you talk about the digital signals, they're not as exact as the analog signals, okay? But since it is in the digital form, okay, since we are having the fixed finite limits of values, and that is why it is quite easy to deal with, okay? So that is, these are the few advantages of digital signals over the analog signals, or we can say disadvantages of digital signals over the analog signal, right? So this is one example. Suppose a digital thermostat in a room displays a temperature of 72 degree. Okay. So now if you see, as it is mentioned, the analog signals provide the exact values. So if you use an analog thermometer, then it will give you the exact temperature 72.482 degree. Okay. So that is the analog value, which is continuous and it is more accurate. On the other hand, if you use the digital value, if you use the digital thermometer, the digital value is more than adequate for the applications. Okay, so it will exactly not give you the exact value, but however it will just give you some kind of finite information regarding those values. Yeah, next slide please. Okay, now if you see, if you just talk about the analog signals, as I mentioned, it provides a continuous range of values. So if you look at the graph of the analog signals, as you can see, if you see here, this is the continuous range of values. It provides the range in the form of sinusoidal waves. All of you see, this is the sine wave. Okay, it can have any time varying signal. Okay, so this is the time varying signals which varies with the time period, right? So minimum and maximum values can be either positive or negative here. If you see the maximum values here, it is the positive. It is lying above this range 0 volt, so it is positive. And the minimum value can be negative because it is lying below this line of 0 volt, right? So they can be periodic or non-periodic in nature. Periodic means which repeats after certain interval of times, and non-periodic means it does not repeats after certain intervals of time. So it is quite irrelevant. Okay, periodic, that non-periodic value. However, the non-periodic signals can be converted into the periodic form through some ways. Okay, so the sine waves and square waves are the two common examples of the analog signals. As you can see, this is an example of a sine wave. If you draw the sine wave graph, and this is an example of a square wave because it is in the squared form. So both these can be considered as a representation of an analog signal, right? And this is the random periodic signals, which is, as you can see, it is providing some kind of random graphs. So this is the diagrammatic graphical representation of an analog signal.